What is file allocation in OS? Whenever a hard disk is formatted, a system has many small areas called blocks or sectors that are used to store any kind of file. File allocation methods are different ways by which the operating system stores information in memory blocks, thus allowing the hard drive to be utilized efficiently and the file to be accessed. Below are the types of file allocation methods in the operating system. So the first one is contiguous allocation. Contiguous allocation is a disk, disk space allocation technique used in operating system. Contiguous allocation is a method of organizing and storing files on a computer's storage device where each where each file occupies a contiguous block of space on the disk. In other words, the entire file is stored in a single, uninterrupted sequence of disk blocks. This method is in contrast to non-contiguous allocation, where a file can be scratched in different locations on the disk. So in this technique, files are stored in a contiguous blocks of disk space. Assuming a file needs n number of blocks in the disk and the file begins with a block at position x. So the next block to be assigned to it will be x plus 1, x plus 2, x plus 3 and so on x plus n minus 1 so that they are in a contiguous manner. So we can understand properly by this example. So looking into the contiguous allocation advantages. So the first one is simplicity and efficiency. Contiguous allocation is simple to implement and efficient in terms of accessing and retrieving data. Since the entire file is stored in a single block, there is minimal overhead in tracking and managing file fragments. So the next one is easy to implement and understand. And sequential access. Contiguous allocation is well suited for applications that require sequential access to data, such as video or audio streaming. The sequential nature of data makes it easier to read and write data continuously. So the next one is memory access is faster and suitable for the system with the fixed size files and limited fragmentation. There is a minimum amount of seek time, reduced fragmentation. Contiguous allocation requires external fragmentation where free space is scattered throughout the disk. This is because each file occupies a contiguous block of space and free space is more likely to be contiguous. So the disk head moment is minimum. So looking into the disadvantages of contiguous allocation. Fragmentation can occur when files are created, modified and deleted leading to inefficient use of disk space. It is challenging to allocate contiguous space for large files. Files cannot grow dynamically, which may lead to wastage of disk space. At the time of creation, the file size must be initialized. As it is pre-initialized, the size cannot increase. And limited flexibility. Contiguous allocation can be inflexible when it comes to accommodating changes in the file size. If a file needs to grow beyond its allocated space, it may have to be moved to a larger contiguous space, which can be a time-consuming process. And difficulty in allocation. As the disk becomes more populated, finding a contiguous block of free space large enough to accommodate a file may become challenging. This can lead to inefficient use of disk space and increased time to allocate space for new files. So, in summary, while contiguous allocation offers simplicity and efficiency, it comes with a challenging related to fragmentation and flexibility issues. Modern file system often uses a combination of contiguous and non-contiguous allocation strategies to strike a balance between efficiency and adaptability.
Coming to the linked allocation. Linked allocation is a disk space allocation technique where files are stored as a linked list of disk blocks. Linked allocation typically refers to a method of organizing and storing data structures in computer science, particularly in the context of file system. In linked allocation, files are stored as linked list of blocks, where each block points to the next one in the sequence. This allows for dynamic allocation of storage space and efficient use of available memory. It contrasts with other allocation methods like contiguous allocation. Coming to the advantages of linked allocation. First of all, dynamic size. Linked allocation allows for dynamic size adjustments of files, accommodating changes in storage requirements without the need for contiguous blocks. Second one is no fragmentation. Unlike contiguous allocation, linked allocation does not suffer from fragmentation issues as files can be scattered across non-contiguous blocks. Coming to the third advantage, ease of insertion deletion. Addition or removing blocks is relatively straightforward in linked allocation as it involves adjusting pointers in the linked list. Efficient space utilization. It facilitates It facilitates efficient utilization of storage space since blocks can be scattered, minimizing wastage space. Coming to the fifth advantage, simplifies file expansion. Expanding a file is Expanding a file is easier as it involves adding new blocks to the linked list without worrying about contiguous free space. Easy to handle files of varying sizes. Dynamic file growth is possible without the need for contiguous space allocation. There is no external fragmentation. The directory entry just needs the address of starting block. The memory is not needed in contiguous form. It is more flexible than contiguous file allocation. Coming to the linked allocation disadvantages. Accessing a file requires traversing the linked list, resulting in slower file access. Disk space overhead due to storing pointers in each block. Increased disk IO operations for file access. At the time of creation, the file size must be initialized. As it is pre-initialized, the size cannot increase it. Due to its constrained allocation, it is possible that the disk would fragment internally or externally. Uh, Sequential access advantage. Sequential access is more efficient than random access in linked allocation, making it less suitable for certain types of application. Potential for fragmentation. While linked allocation avoids external fragmentation, it may still face internal fragmentation due to variable block sizes. Complex implementation. Managing and manipulating the linked list structure can be more complex than other allocation methods, especially for large files. Complex implementation. Depend, Dependency on disk structure. The efficientness of linked allocation is influenced by the disk structure and how efficiently it can handle scattered blocks. Not ideal for real-time system. In In real time systems where quick and predictable access is crucial, linked allocation may not be the most suitable choice due to potential delays in access scatters block. And coming to indexed allocation. Indexed allocation is a file allocation method used in computer systems to manage and organize files on storage device such as hot devices. Unlike contiguous or linked allocation, indexed allocation employs an index or table structure to keep track of file blocks locations. Here, detailed introduction to indexed allocation. Basic concept. In indexed allocation, each file has its own index block, often referred to as an index table or index node. This index block contains pointers to the actual data blocks of the file instead of scattering points throughout the disk. As in linked allocation, all the files pointers are stored in a centralized index constructed. Coming to the index allocation advantages. First of all, fast access. Indexed allocation enables fast access to any block of file since the file block directly points to the corresponding data block. Second one is random access. It supports efficient random access to file blocks, making it suitable for applications where quick data retrieval is essential. Coming to the third one, dynamic file growth. File can easily grow or shrink in size without the need for contiguous space, providing flexibility in storage management. Coming to fourth advantage, reduce fragmentation. Unlike contiguous allocation, indexed allocation helps avoid external fragmentation as file can be scattered across non-contiguous block. Coming to the disadvantages of index allocation. Index block overhead. Each file incurs an additional overhead for its index block, consuming extra storage space. Sequential access overhead. While random access is efficient, sequentially access might involve extra steps as the system needs to follow the index structure to reach the desired block. Limited size of index block. The size of the index block sets a limit on the number of pointers it can hold, potentially limiting the size of files that can be efficiently managed.
So let's see the overview of three allocation methods. So the first one is contiguous allocation. Contiguous allocation is a file allocation method where each file occupies a consequent block of storage space on the disk. In this approach, the entire file is stored in one continuous sequence of disk blocks. The simplicity makes file access and retrieval more efficient, especially for application with sequential access patterns such as streaming media. So the next one is linked allocation. Linked allocation is a file allocation method where each file is represented as a linked list of disk, disk blocks. Each block contains a pointer to the next block in the file. This eliminates external fragmentation since files can be scattered across the disk and each block contains a reference to the subsequent block, creating a chain-like structure. However, accessing data in a linked allocation system can be slower than in contiguous allocation. And the last one is indexed allocation. In indexed allocation, a separate index block is used to store pointers to each block of the file. The indexed block acts as a table of contents allowing for direct access to any block in the file. Indexed allocation is more efficient than linked allocation in terms of access time. So, thank you.